we will be talking about sepsis. He's done quite a lot of work. He got quite a lot of money for research. It's IT intensivist, Roy Glenn. And look forward to his talk.
Right, thank you very much for the invitation. I'd like to talk about the lessons that we have learned during our journey to develop a sepsis biomarker panel. And there were some unexpected results in this. And one of the first unexpected results is that I have to declare conflict of interest because, as Michael said, I did get some money for this research. And we did have a patent which is submitted. Now, I did not envisage that this is a result when I started the biomarker research about 20 years ago back home in Hungary. So it was a nice unexpected one. 20 years ago, we were in a really easy situation because we knew what sepsis is. We knew what sepsis is because we just had a new definition published in 1995, and that was the first one which actually tried to bring this syndrome together, and everybody was really keen that now we know what we are talking about. Let's do some research and let's find some biomarkers. So in the next about 10-15 years, there was an explosion of papers on different biomarkers, metabolites, procalcitonin, CRP, IL this, IL that, TNF, which was talking about that this is the biomarker that we can use to diagnose sepsis, to actually try to get distinction between organ dysfunction which is caused by infection and organ dysfunction which is not caused by infection. Now everybody was looking for the special one. Okay, and at times we did think that we did find the special one, and then I think over the years it became clear that you can't find the special one. You can find the special one if you put it in the right context. So this guy was the special one when he was in the right context, and then he's a really good one when he is not in the right context. And this is really, really true with the biomarkers. And when we are defining a sepsis biomarker panel, this was one of the lessons that we have learned, and this was one of the things which are important. About 5 years ago, researchers started to put one and one together, and then we all thought that okay, if we start to put these things together, then you will have a better result. And unfortunately, in sepsis and in biomedical science, basically, based on what Michael said to us earlier, 1 plus 1 is not equals 2. And if you just combine a couple of biomarker panel or biomarkers, then you will not have a better description. Especially if you are trying to use a really mechanistic approach. And this was another thing which we have learned when we were looking at defining a sepsis biomarker panel, because we cannot use a very simplistic mechanistic approach to do this. And why? Because our brain works differently. You've heard the previous presentation that the brain activates, for instance, for pain, very different areas, and that combined activation will give us the result. And this is the same when you are at the bedside, and when you are looking at a patient, and when you are looking to analyze the data which is available for you. You are not doing 1 plus 1 equals 2. You are doing a much finer resolution of the work, and this is very difficult to put into an algorithm. And for a number of years, it was close to impossible to try to do that. So When we are looking at to define a sepsis biomarker panel, this is one of the important points to mention, that we have to think laterally. And we still went simplistic, because when you go for a grant application, you have to simplify what you want to do. And when we went to the TSB panel almost 5-6 years ago, we went in that we knew that there was a huge area of biomarker research done. There were a lot of publications. We knew a lot about what could be good, what could not be really useful. And we went in and said that we would like to see if we've got a patient, can we decide, very simple, health and inflammation, then severe inflammation, which is not an infective origin. Looking at sepsis, whatever sepsis is nowadays, I don't know. I spent the last 10 years researching sepsis. I've got no idea what it is now. But to look at whether that is a pulmonary infection or an abdominal infection, and this was what we put forward. And although it's a very simplistic model, it a little bit resembles your thinking at the bedside, and that's why probably it was picked. We also entered the matrix, and we entered the matrix because we learned that lateral thinking and not mechanistic thinking is the way forward. So we combined forces with Nottingham Trent University, with Prof. Graham Ball, who is the bioinformatics professor there, and we have used his developed artificial neural network analysis, which he developed for cancer. And he especially did a lot of work on breast cancer. This method of analyzing the data and doing an iterative analysis, feeding it back to the algorithm and try to learn from its mistakes within the constraints of the model seems to be very useful. And Nottingham is a world-leading center in terms of breast cancer, not just diagnosis, but treatment based on the biomarker research that they have done. So we thought that if they have developed it for cancer, can we use it for sepsis? And that's what we tried to do. Now, when you think about defining a sepsis biomarker panel, there are two different ways to go for it. You can go the easy way and you can measure proteins. And we measured, if I remember correctly, 54 different protein markers in our patients. We recruited 186 patients in 4 hospitals. We had a very clearly defined clinical criteria. We had patients with abdominal sepsis in one group who had basically perforated bowel emergency laparotomy coming into the ICU. We had patients who came in with a community-acquired pneumonia, which started early, so we were focusing on the early phase and the community-acquired infection. And as a control group, we had out-of-hospital cardiac arrest patients who did not receive any antibiotics because they deemed to be non-infected. Those were our control groups. And we had age-matched healthy volunteers, and I'm really grateful for the staff at Cardiff University who gave their blood for our research. So we measured these biomarkers, and we tried to put it into the artificial neural network analysis, and we found a panel. And we found a panel which is slightly surprising. When I saw the first iteration of this panel, it looked completely different. Well, not completely different, but 4 out of the 5 were different markers at that point. But when you start using the computer power to look laterally, not just down on one group, then you start to pick up other messages. And these are the messages that we picked up. Now, interestingly, when you just look at severe inflammation and try to put it into non-infective and infective origin of organ dysfunction, these markers, they do make sense. They do make a lot of biological sense. They all, at the neutrophil macrophage interface, they all at the interface where the neutrophils are activated and then they start to do their killing. And it seems that if you combine these markers, then you can actually do differentiate between SIRS and sepsis, or whatever it is now. SIRS is not there anymore. Non-infective origin of organ dysfunction. Could we do that? Each bar represents one patient. The red ones are the patients who we had a confirmed infection. And as you can see, when you combine these biomarkers, on day 1 of ICU admission, you can have really good cutoffs where you can say, yes, it is infective, no, it's not infective. And then you can start to work on, and you can, once you have that category, then you can look into your biomarker panel and then try to tease out other things. The overall ROC, if you are ever interested in that, was quite good for a protein biomarker panel. At day 5, because we followed these patients up, so we didn't just do one day, we had a daily, a little bit more temporal measurement. Day 5, the biomarker panel has changed. So your patient is already on the ICU. You've got an idea that why did they go in, but do they have sepsis on day 5? And this panel can give you a very good description. So this was one of the important points that we have discovered in this biomarker panel. And does it fit the biology? When you look at what we call chronic intensive care syndrome or persistent inflammation, these biomarkers were all implicated in getting the acute inflammation into the chronic phase and getting that patient who is severely acutely unwell for the first 5 days, we got them out of their septic shock, but they are still at high risk of death. Those biomarkers are all implicated in that catabolic state and persistent inflammation. Now, obviously, the results are not so good. At day 5, there is a lot of noise because one patient is transitioning to the other group, the other patient could transition. So the ROC is slightly less impressive, but still you can have a relatively good discrimination. In my daily practice, I would take it. I would take it any time because my current thinking is a lot less successful than 0.78 at the ROC curve. Now, we thought that it's good, but can we get better? And then we thought that, okay, the proteins are translated. So there is something before proteins, and let's try to see if that works. So we turned into mRNA, and messenger RNA mainly from the leukocyte population, not from whole blood mRNA. There are a couple of really nice studies which show that you can actually pick up using the mRNA a much higher resolution of the picture compared to using protein. And it wasn't just us who looked at it. The Septicite lab, ImmuneXpress, has published some really exciting results where they could put a biomarker panel together, and looking at the expression of the mRNA biomarkers, they could differentiate between sepsis and non-infectious origin And these were their results. So it looked really good. The real problem with mRNA is that at this moment we don't have the technology to make it available close to the bedside, or even very rapidly available in a central lab. So this is a real problem, and this is what we have learned when we were developing our sepsis biomarker panel, that this will be one of the big drawbacks. Now, I've learned other things. I've learned to work with really clever scientists who taught me about how to interpret these plots. And on face value, you can see that there is quite a bit of noise above the line of 1.1, 1.2, but actually the clustering of the patients are very good in when you look at fold changes in mRNA expression levels. And we have seen that they can actually distinguish between patients with sepsis and non-infective origin of inflammation. And this is what we come up with in terms of mRNA markers. Does it fit the biology? It certainly does. When you look at the severe inflammation, sepsis and SIRS, that's all bar the RH, GF, and L. All the other three are actually markers of deranged hematological and platelet function. And that fits with our current understanding of sepsis, that there is an activation of the neutrophils, which will turn into an activation of the platelets and the coagulation cascade, and that will cause macroscopic and end organ damage. And that's what we have picked up. And if you look at the expression of these molecules, those were the best ones that we could pick up. Now, the other ones between pulmonary and abdominal sepsis, there are two molecules. Again, the pulmonary type is more involved in the coagulation. It's probably the bugs which are causing the problem there. They are activating the coagulation cascade, so that's why we can pick those up. Whereas in the abdominal side, the two mRNA segments, they are more involved in the neutrophil activation and TNF-alpha production. So these all fit the biology, and we are quite confident that these markers will perform well at the bedside, if it ever goes to the bedside, once we've got the technology to put it next to the patient. But actually, this is really important, and it was really exciting, but it was not the most important part that we have learned when we defined our sepsis biomarker panels. Because what we have learned, that actually collecting that vast amount of data and vast amount of information, we can pick up new things. And then we have picked up biomarkers which we never thought that they would be useful. One of our current avenues that we are pursuing is to look at prognostication after cardiac arrest, which is a huge problem on the ICU. I've got my out-of-hospital cardiac arrest patient in. I know that I cannot prognosticate for neurological outcome for about 5 days. And even after 5 days, I'm left with just my clinical judgment and a couple of now you can say rudimentary ways of prognostication, doing a CT scan, doing an MRI scan, doing an EEG, and having a really good look and having time. Now, during this work, we have picked up a couple of markers which we never thought that we will pick up. And it looks like that first they were prognosticating death in the whole cohort. But when you analyze the data and when you've got a huge data set and you can analyze it, then it does seem like that NECAP1 is actually, could be a very good prognosticator for neurological outcome after cardiac arrest. And NECAP1, you can bring it out in the mRNA panel, but you can do it with an ELISA. You can do it as a protein, and it could be something which is really useful. So when you try to define sepsis biomarker panel, then you will have unexpected results. And then whilst if you set out to do something, then most of the time you can actually achieve what you want. But if you think laterally, then you can have some really unexpected results, which could be more important than the ones that you started to achieve at the first time. And with that, thank you very much.